Hi, this is Mr. Shumway. I made this video clip to explain a few problems that have to do with heat capacity. We'll do one in this video, one in the next. So when you apply brakes in a car, friction between the brake discs and the brake pads converts translational kinetic energy into internal energy, which we experience as heat. So if a 1,000 kilogram car traveling at 30 meters per second comes to a stop after its brakes are applied, how much will a temperature rise in each of the 3 kilogram brake discs? So we will assume that the discs are made of metal with a heat capacity of 500 joules per kilogram. That's about right for steel. Let's also assume that the heat is evenly distributed between all 4 brakes. Okay, so let's figure out how much energy we have, how much kinetic energy. Kinetic energy is 1/2 mv squared. Well, we have 1/2 of 1,000 kilograms times 30 meters per second squared. Well, that turns out to be, well, half of 1,000 is 500. 30 squared is 900. So we have 45 with 4 zeros. 450,000 joules that need to be dissipated between the 4 brakes. Well, we have 4 pads times 3 kilograms. So we have 12 kilograms of steel, and each kilogram can dissipate 500 joules. So those brakes can dissipate 6,000 joules of heat for every degree in temperature that they rise. So we have 450,000 joules, and 6,000 joules makes the temperature rise 1 degree. Joules per degree. So we just have 1 over degrees, which is degrees. The units are degrees. 450 divided by 6. That equals 75. So the brakes should warm up 75 degrees. Well, that may not be a big deal if you stop once, but if they're warm already from coming downhill, and they can keep warming up and keep warming up, so you have to be careful going down hills. Trucks often get their brakes just too hot. Looks like we have enough time to do both of them. So let's say we have a hot water heater. It's operated by a solar power. If the solar collector has an area of 10 square meters and the power delivered by sunlight is 420 watts for every square meter, how long will it take to increase the temperature of 1/2 of a cubic meter of water, 20 degrees Celsius, from 20 degrees Celsius to 50 degrees, and a watt is a joule per second, and a cubic centimeter of water is 1 gram, has a mass of 1 gram. So we can do those conversion factors. So the total increase is 30 degrees. So we should figure out how much mass a cubic meter of water has. So we have 1/2 of a cubic meter, and we know there are 100 centimeters for every meter. We have to do that 3 times. there are 3 dimensions to a cubic meter. All 3 of those cancel 1. Now we have 500,000 cubic centimeters, and each cubic centimeter weighs 1 gram. And we know there are 1 kilogram for 1,000 grams. Thousand grams is 1 kilogram. How do I know if I'm multiplying which one's on top, which one's on bottom? Well, I put them so that they will cancel. The units will cancel. And cubic centimeters cancel all of the centimeter units. So the only units left are kilograms. So we've converted it from a volume to a mass. Well, there's a million. If I multiply it 3 times, if I divide that by 1,000, that gives me 1,000. Then I divide by 2, that gives me 500. 500 kilograms. You can just multiply everything across the top, divide by anything that's in the denominator. And I need to multiply by, we're going to do 30 degrees, and it takes 400. Water takes 4,200 joules for every degree that it's going to rise. So the degrees cancel, and we can collect 420, well, 4,200, because we have 10 square meters. Per joules per second per square meter, and we have 10 square meters. So square meters cancel, the joules cancel, and we just have 420 joules per kilogram per degree. Kilograms cancel. So anyways, the 420 times 10 is 4,200, so those cancel. We have 15,000 seconds. We have 1 over second, so the only units we have left are seconds. 15,000 seconds. Okay, let's do unit conversions. Let's do 15,000 seconds times, there's 1 minute for every 60 seconds. So that, dividing by 60 would give us minutes. And there is 1 hour for every 60 minutes. So we divide by 60 twice. That gives us 4.2 hours. So it will take about 4.2 hours to heat a half a cubic meter of water 30 degrees.